if I've done it properly, I hit stream, and now all of this is being recorded. So go like this, and then let me call up a YouTube. Oh, I could have just clicked on the side, but now if you go to the Google Classroom, you can actually find the link in there. Anyway, I've apparently played too much Baldur's Gate, and it has decided to advertise to me. Live. Now, you don't have to go through this rigmarole. You can just find it if you go to my link. I've got to do this because it knows I have the video, so it thinks I want to edit it, when all I want to do is display it and prove to you what it's doing. And so it is not recording you unless I hook it up to a camera, which I can do if I have a demo that I think I can actually film in some kind of way. So it's just whatever goes on here, which is why I've gone through the rigmarole of getting this working, because I can't write on that projector, but I can write on this screen, and that way there's a copy of the notes and kind of the things I say. You can hear that it's definitely picking up my voice. The microphones are not right there. Someone last year thought that was a giant eye and it was recording them. It's not. It's just a microphone. It's a mid-range, not great. If any of you are Twitch streamers, you probably have a better microphone than I do. But so we'll get rid of that. And I'll shut off the sound because that's annoying. And stop that from running. Put that away. It's not that one. No. We are going to do start on the board model. It's going to be mostly review notes for that. But for today, what I'd like you to start. Why is that there? Is I'm going to give you a little. We had the Saturday class. I don't like giving homework on a Saturday class because you don't have a prep. You are, so that you're aware, technically at this school, although I have not heard it from the mouth of Miss Allen herself, but I think the rule is still in effect. You are not allowed to have an assignment due on Monday that was assigned to you on a Saturday, because you need to have a prep in between the two. Now, you can have something due on Monday that was assigned to you on like a Thursday because you had two preps in between that. But your teacher shouldn't be doing that. And like most things, you will tell your teacher that, and you will object, and they'll go, too bad. So, I don't know what that means. But that's supposed to be a rule. Last day you did the lab. You should have your observations, your materials, and your procedure. Finish off your table by drawing the line if you need to. And then what I would like you to do, I'm going to give you some time right now to start to write your discussion in the lab book. So you make a separate heading, discussion. Don't forget to put the name, date, and page number on every page you turn over. You are not, what do you have to write in? Pen. So no pencil. You have to date, name, and write a page number on every single page. If you wanted to sit down one night and do the whole book, you're welcome to. But you don't have to. You can do it as you go along. And here's the kinds of things I wanted you to think about for your discussion. So one of the things I said is like think about like what is a chemical reaction, what is a physical reaction. So this is not a lab like a lot of investigative labs. A lot of labs you come up with a hypothesis. So you've observed something about the universe. Rocks fall down, and you go, I have questions as to why rocks fall down. Perhaps they wouldn't fall down if we shielded them with lead and they'll float, and you'd then come up with an experiment. My hypothesis is that lead shielding will stop gravity from working. You do the experiment and figure out no. But we had no hypothesis. Our lab was very similar to some like biology labs where you just go in the field and you observe and you just write down your observations. That's a longish-necked, weird, oblong creature with two eyes and black and white stripes. I shall call it a zebra. And then you write it down, and you write everything you can see about zebras. There was no hypothesis. You're just observing. This was an observing lab. We didn't make a hypothesis as to what was happening. You just observed what was happening. That is the first step in any scientific investigation, is to have good observations. The only difference between just messing around in science is writing it down. If you write it down, you now have data. So what I want you now, with those ideas of reactions in mind, and you observed what happened, what questions do you have? Because, why did it do that? What exactly do you observe? What caused it to change whatever it changed? come up with some possible explanations for your questions. You can't prove them because you didn't do them in the lab, but you might have some explanations there. And then if you were to do this experiment again, what would you change about it? So what would you redo to test some of your questions to answer it either way? So if you were like, I think that the little black snake that came up was actually a living being. And I think the heat just made it really excited and it grew. Then you may have a future experiment where you I'm going to take the pills beforehand and I'm going to autoclave them. Autoclaving them is heating them under pressure to a high enough temperature where they don't burn, but it kills every living thing. It's something you do at a hospital to sterilize instruments. And so you would do that and repeat the experiment. If you didn't get a black snake, then you would know it might be a living thing, because that would now be supported by the hypothesis. If they still grew, then you would know it was something that wasn't from a living thing because you killed all the living things. So that's an idea, perhaps a little silly one, of an explanation and then a hypothesis that you may have for a future experiment. You don't have to write up a full procedure, but just a bit of a I would do this and this to see what it would do. So I'm going to give you some time now to write it, do it, and then I'm going to stop you. We're going to do some notes. And it will be due our next class. So not tomorrow, but what day is it today? It's Tuesday, so it would be due Thursday. Good. Any questions? Concerns? Existential crises? Okay, excellent. Good. Oh, and while you're doing that, I realize that I didn't take attendance for the first class. So I better enter that now.
I feel like once the product made up, it's just black and green. Maybe it's not. I just made that one because that was the reaction. So something might have changed.
You can start on a new page. You can write discussion, like we'll use the title page. Keep going. Name, date, page number. You just, one thing I didn't mention, it's in your thing on how to write up a lab. Unlike observations, discussions should be in whole sentences.
So we ask her.
So complete sentences answering questions, not point form. possible explanations or ideas. You're allowed to collaborate. You're writing your own work down, but it's just very silent in here. In case you thought you weren't allowed to talk. This is not like a quiz where you were working on it completely. Scientists collaborate a lot of the time. That is what it's doing. Yeah. So I'll probably go to 12:15.
Does it have to be in tablet?
So a bit of time in class, and then that way it gave you a chance to ask any questions, and then the rest of it.
Does it have to be a solid mass? I don't know. I'm thinking like maybe the Sept. Does it have to be solid mass? Could it be? Could the virus tablet be different from the virus Yes, exactly.
seconds.
Does the vitamin C have certain properties to make it grow? Like compared to like vitamin A?
your lab books away. Have them ready to hand in on Thursday. And we will. Oh, I haven't opened it up yet. Right. We are. This is B block, is it not?
I thought C.
Is this C block?
It's B.
If you thought it was C because it's the last block, the blocks always follow the blocks, but they don't start with the blocks. And what I mean like that, you can have an ABC day, you can have a BCA day, and you can have a CAB day, but you can never have an ACD day. It always goes in alphabetical order, but when it gets to the third one, it repeats. Did that make a lot of sense? Yeah. Okay. What actually is chemistry? Yeah.
The study of elements of matter.
Study of matter. Elements are a form of matter, so that puts a point in it. Matter, and there's actually another thing going on. What's not matter? Atoms are a form of matter.
Would have been missed.
Pardon? Energy. Because you take matter and you apply different forms of energy and it will do different things. We're going to restrict ourselves to regular chemical means. I'll mention nuclear stuff once in a while because that's where the wild and woolly stuff sometimes happens. But in terms of our chemistry, we're going to do like basic chemistry. We're not going to be throwing it in particle accelerators or worrying about how it's going to change. Now, that means that chemistry is actually the study of absolutely everything. There's not a single science that actually just isn't chemistry in some other disguise. We give them other areas because when we say chemistry, we tend to mean test tubes on a desk and we're doing like some pretty direct things and we're watching the molecules change. But that is what every science does. They just restrict themselves to certain areas. Or if you don't believe me, what form of science do you think not involve chemistry? Yeah. Biology. Biology is fundamentally based on carbon-based life forms on this planet anyway. And so it's the interaction of carbon in other ways. So you can imagine if you're looking at neuroscience, you're down to the neuron, which is just neurotransmitters moving across to a membrane, exciting it, instituting a change in energy. So voltage fires, and that's what we call thinking. So at the end, it's just biochemistry. They're made of atoms, they undergo energy changes, and so biology is just biochemistry. Any elements? Yeah.
Math.
Pardon?
Math.
Oh, math isn't a science at all. Math is a tool that we made up. We just invented it, and it doesn't actually exist. It exists in the same way that Darth Vader exists. We invented Darth Vader for a purpose. And so he fulfills his purpose. Same with math. But you can invent forms of math. We invent the forms that are most useful to us. And so we go, well, math is true. Yeah, it's true because we invented it that way. You can invent forms of math that don't fit that purpose. For example, and you may be thinking, what kind of math doesn't do that? Imagine, if you will, a universe. In our universe, this is equal to?
4.
Yeah, of course it is. Yeah. And if I said 14. However, there is a type of math. Ms. Walensky, I believe, knows this person. They are working on a very advanced form of math. They are a pure mathematician. This is what they do for a living. And they would say, in their particular system, they might say something like this. That is a completely valid form of math. You can make up different math. Does anybody know how you can get 10 plus 4 equals 2? The weird thing is you do this every day. If I went 8 plus 8, then it would be 4. If you want to test it, Give me a sum and I'll tell you the answer. 5 plus 3 in this brand new form of math does in fact equal 8. So they're the same in both universes.
Is it just like the symbols mean like different values?
Nope, they mean exactly the same
Does
thing.
the number start with 12?
Pardon?
Like 14 is 12 plus 2 and 16 is 12.
Ooh, you've noticed the pattern. Where do you do that kind of math? Because you do that kind. I deliberately chose the example you're familiar with. Where does that type of math happen?
Sequences?
What kind of sequences? What value is this type of math used in all the time? You've seen it on walls every day. Maybe not as much nowadays. They usually round objects. Students look at them a lot during a test. Time. We have 12, 6, 3, 9, and you go like that. And if it is currently 10 o'clock, and you add 4 hours, what time is it? It's 2 o'clock. You do that all the time. And that's because we use a form of math, normally, that has a straight number line. But forms of math that have a curved number line exist. And she doesn't use a 12-based system necessarily, but she works in a field of math where all of the number lines are curved and repeat on themselves. And that has led to some very interesting discoveries about the nature of fundamental theorems. Math, as we know it, is currently broken. It is fundamentally broken on a deep level that shows us that it doesn't work. And I love this about it. They've solved this problem with what they call the naive theory. The naive theory is literally where they say, we pretend it's not broken, and it just kind of works. And we're all just going to pretend that. That's the naive solution to that particular problem. If you want to know, it's fairly easy to explain how it's broken. Yet you are aware of math that has, you're aware of sets of numbers? Give me a type of number. What type of numbers do you know? Real numbers. What are real numbers? If I were to define a real number, what's a real number? 0 to infinity? Does it include negative numbers?
Yes.
Yeah. So, there you go. And you can make sets of numbers. What's another set of numbers that isn't real numbers? Pardon? Imaginary numbers? Imaginary numbers include the square root of -1, and you can have different variations of that, and they are not in the real numbers. The set of all real numbers also includes other sets. So, like, there's the integers. So we could have positive numbers not including zeros. I think those are like natural numbers or something. There's all sorts of numbers. You can make sets. You can also make sets of sets. You could have a set of real numbers and imaginary numbers. A very famous mathematician whose name escapes me because my background's biochemistry, not math. Ms. Walensky knows it. Ms. Walensky is my house parent, so I'm like one of those people like, Ms. Walensky knows everything. And what he said, I have a set of numbers that contains all sets. That does not contain itself. So all the sets of all the numbers that do not also contain themselves are in this set. It doesn't even matter if there's any sets that follow those rules. That's just the rule. And the question was, does this set contain itself? Because if it does contain itself, it belongs in the set. But if it belongs in the set, then it should not contain itself, and therefore it no longer belongs to itself. And that is not just like, haha, we confused the robot with a logical error. This is a fundamental error at the basis of mathematics. You can essentially go from this. This is like saying that A equals not A. And from this, you can prove anything. Because if you can have a contradiction in math, then you can prove anything. Because once you start with a contradiction, you can prove all sorts of untrue things. So we deal with this by ignoring it. So that was a really long explanation to say, Math isn't a science. We don't do experiments in math. We don't get a bunch of rocks and go like, I have 2 rocks, and I chuck 2 rocks, and now I got 4 rocks. Nobody does that. And it's true that there's 4 rocks, but imagine a universe, you woke up tomorrow, you had 2 rocks, and you added 2 rocks, and you had 3. Is math wrong? No. The math 2 plus 2 still equals 4. Math is always right because we invented it. If the universe does something different, the universe is wrong. And you can invent math that describes different universes. We happen to like the math that describes our own because it's really useful. There are forms of math that we never thought we used, and it turns out it actually described a pocket part of our universe. There's quantum mathematics that nobody ever thought they'd use, and it turns out really valuable. It does describe our universe some way. So yeah, math isn't a science. Geology is just earth chemistry. Astronomy is just stellar chemistry and nuclear chemistry of stars. Psychology is just biochemistry. Biology is just biochemistry. There is no science that isn't fundamentally chemistry. We're going to start off with chemistry, and then we're going to do some biology, chemistry. We do biology, we do genetics, and then we're going to do some physics. Really easy chemistry because the stuff isn't going to even change form as we're going across. So chemistry is the study of matter and energy, but now we have to define matter. Matter.
Yeah.
I like you just drew it out. It is not everything. I mean, if I go like this and I said there's no matter here, you would know I'm lying because I can feel the matter there, which is a clue. But let's say that I closed the doors, and it's a brand new building, so it's airtight, and I sucked all the air out. And I was on the outside laughing as you're all like, oh. But at that point, there's no matter. So we can have things that aren't matter. What is matter? What does matter possess that non-matter does not?
Oh, wait, matter is liquid, solid, and gas?
Those are different forms of matter, specifically phases of matter. But yeah. You are leaping way ahead. So you've defined an atom, which is like way up here. It's called the atom, which is the tiniest piece of matter. But how do we know what is a property of, like, how did I know that there, I can't see the matter, but I can feel it. What am I feeling there?
You're feeling particles?
I'm feeling particles, so what's giving me this? Because would I feel this if this was a vacuum before I suffocated?
What?
Like if I was doing this and you ran out, sucked all the air out, and I'm like, what would be different about this feeling? Mm-hmm. There'd be no mass. There'd be no mass. You push against mass. If you're on the space station and you need to record the mass of something, you don't have a weight scale. Weight and mass are actually technically different things. We've just defined it on planet Earth so that the weight and mass are identical at about sea level. But if you're on the space station, you still have your mass. You just can't feel it in the same way. So all they do is they take it and they put it in a special machine, and the special machine just jostles it and shakes it really hard. And then you can feel how hard it is to push. You can measure the mass. It has one other thing. Mass and volume. So it takes up space. There are weird things out there. A light is a particle and a wave and maybe a form of energy. It has momentum but no mass. So we're not going to discuss that one because it's in an almost special classification on its own. It's also a theory that there's only one electron in the entire universe, only one electron. It's just going backwards and forwards in time and repeating itself, so it is everywhere all at once. And that's why all electrons look the same. Not all protons actually look the same, but all electrons do. There are very tiny differences sometimes between protons, but not between electrons. So one theory that we can't disprove, so if we can get an experiment and do something, that would be great. But one realistic obeys all the laws. It's just one electron going backward and forward in time. And that makes up all the electrons. Yeah. I'm not saying that's true. I'm just saying we can't say it's not true. Everything is made up of 100 building blocks. What do you call those building blocks? Quarks? Oh, you're going too deep. Not quarks. Elements, yes. That was like 2 layers too deep. Yeah. Like quarks and mesons and stuff make up the other subatomic. So that was like subatomic particles. We're going to pretend those things don't exist. What is an element?
It's a substance or a chemical.
It is.
It is.
So is water, which is not an element.
No.
Yeah?
It's a specific like combination of protons and electrons.
It is a specific combination of protons and electrons. I really like how you left out the neutrons because they can vary in isotopes. I'm not going to do it in the, that's the nuclear definition. One of the things I wanted to say, it is like water, it can be pure, but one of the fundamental ways that we defined an element is that the early alchemists would take matter and they would try and break it apart by chemical means. So they took water, and one of the amazing discoveries is that water wasn't an element. A guy took off water and he broke it in half, and he discovered that if he pumped what came out of water from one side, it would kill the plants. And if he pumped the stuff on the other side, it allowed the plants to grow. So he discovered hydrogen and oxygen. And so he found that water is not an element because you can break it down to other things. And they would keep breaking it down, and eventually they would get to stuff they couldn't break it down anymore. With just a regular laboratory. No particle accelerators, no nuclear chemistry. We're not going to fire things at the speed of light into things. But if we just do normal chemical means, we can't break it down anymore. So it's pure. Someone who hasn't said anything, give me an element, your favorite element. Oxygen. Do you know the formula of oxygen in the room? O2. O2. Oxygen is one of those elements that likes to dance in pairs. You never find free oxygen just as O1. If you do, it's really reactive. That would be very bad for you. But just normal oxygen that you're going to use to burn. O2 is actually really reactive, but that's why we use it to burn food in our mitochondria. And someone else, another element. Oh no, you've said things before. Someone who hasn't? Yes? Did you not wave your hand? Louder. Neon. Oh, neon lights. Nowadays, a lot of neon lights you buy, they're really cheap because they don't actually contain the noble gases. They contain LED lights, and they just put them in a string, and they turn on and they say it's a neon light. And that's why you can get any color. But all the noble gases actually, when you run a current through it, will glow a particular color. And if you want it to glow a different color, you have to coat the tube. And since they glow a particular color, not all colors are available. The reddish one, I think, is neon. Water is also a pure substance. So now I want to distinguish between water and elements. Oh, I gave away. Because I already told you. Is water an element? No. No. Everything changed when the Fire Nation attacked. We can break water into hydrogen and oxygen. We tend to be using battery-operated cars now for doing more and more and getting away from gasoline. But one of the proposals, if we can get a hydrogen car working, we can use a very similar type of engine, generate the energy on the fly, and just combine it with oxygen in the air. And it would also, and its waste product would be water. Not as developed as the battery systems. The battery system beat them, but maybe if we can get it working, it might be a little bit more environmental. The batteries have to be recycled, and so that's always a problem as well. And the elements that we use to make up batteries are often located in very particular mines around the world, And there are civil wars that are fought over those mines because they contain quantities of the elements we need for batteries. And I say that solely to if you have a cell phone and you're like, a new cell phone just came out and I only have last year's cell phone. I should get a new cell phone. If you don't need it, let it. Because every time you buy a new electronic device and it contains a battery, that civil war continues and someone innocent has died. We can't do, because we know the amount that is being used to make our batteries exceeds the amount that is legally and safely mined. So they have to be funding the other side and continuing the war. Everything has to come from somewhere, and you have to either grow it or dig it out of the ground. And so the more we consume, the more we have to go get it. So the less we can consume, the better, and so seize the means of production. All matter can be divided into the tiniest piece, the atom. And we're going to pretend, even though we're going to immediately say it's not true. Well, not true. Because this is technically true. At the point they defined this, they didn't even know what made up the atom. An atom derives from the Latin. If you put the A in front of something, you negate the other word. So you have moral, and you have amoral, someone without morals. Theist, believing in a deity. Atheist, not believing in a deity. Any other A words, where the A in front negates the rest of the word? I'm trying to think of a third. I used to have a third one on the top of my head. Tom is a derivation of Latin that meant split. So atom was something that could not be split, which of course they did a few years later, but we're going to ignore that. If you were to name it in English, it would be an uncleft, something that cannot be cleft in twain. But if we do manage to split it and we put it in a particle accelerator and we spin it around really fast and we hit it against something and we manage to break it, is it still that original element? No. Whatever protons fly off, they now are brand new elements with brand new properties. We are now going to play a bit of a game. I'm going to define these afterwards. You see that we have 5 columns. In those 5 columns, I am not going to put a header on. I'm going to ask you at the end what the headers should be. What I'm going to ask you is for an example of a form of matter. It can be any form of matter that you'd like, and I am going to write them up under the correct column. And then if you get enough examples, I want you to figure out what the columns are. So we're going to sort and classify our matter. And I'm just going to go around first the entire classroom and figure out what things are. So we'll just go shh, and then shh. So go.
What do I say again?
Any form of matter.
Any form of matter?
Yep.
Oxygen?
Oxygen's a form of matter. So that would go right here. Done?
Water.
Water would go here.
A mug.
A mug. Like some
Like a mug.
kind of mug. What kind of mug?
Coffee mug.
No, I'm not talking about what you put into it. Like ceramic,
silver.
Starbucks.
Silver. I changed mine silver.
No, I like mug.
Oh. Okay.
No. But like,
Good.
where did it go?
Things are
Like,
really classy.
I have a mug, and it's got a plastic top on it. Would it be like this mug, or would it be like a classic, like simple ceramic mug?
A simple glass mug.
A glass mug. Oh, that's irritating. Technically speaking, I think a glass mug. Glass. If it's pure glass, I think I can do this. Glass is always one of those funny things. Okay?
That would go ceramic.
Ceramic. So just a ceramic mug. Excellent. That goes over here.
Should we be copying this?
Yep. We're going to get a bunch of examples. Your job is to get at least 3 examples under each header. Go.
Livermore.
A liver?
Livermore, the element.
Livermorium? I've never heard of that element. How do you spell it?
As liver, like liver, and morium, M-O-R-I-U-M.
I'm gonna have to go look that one up. It's not one of the forbidden ones, is it?
It is.
Like the ones that were unnamed?
They were, but it didn't like it like a few years ago.
Oh, okay, cool. Yeah, there's a really good research lab in Japan. Obviously, there's a really good one in the U.S. And they kept finding elements and naming them back and forth. And eventually, IUPAC, the International Union of Pure and Applied Chemistry, went no more, because they'd be like, well, it existed for a whole femtosecond, so therefore it's a real element, and we get to name it. And now it has to exist for like whole portions of a millisecond, and they will judge it. And that way, all those elements they said they made, they said, you didn't really make those. And so they took away all the names, and they gave them the Latin names for their atomic number. And then we'll say, well, wait until you can really prove it. And that has slowed the element discovery. So they've made a new one. That's pretty cool. There. Key. Milk. Ooh, nicely done. You have managed to get up onto the last classification system. Aluminium or aluminum? Aluminum. Excellent. That is here.
Wood.
Wood. Excellent choice. Diamond. So try and avoid the last column if you can. Where was that? Honey. Ooh, yeah. There. Concrete.
Plastic.
What type of plastic?
This type.
What type?
PLA. Big PLA plastic. Like the 3D printer.
Pardon?
PLA plastic.
Purelate?
PLA.
PLA. Oh,
It's like the 3D printer.
yeah. I think I'm going to put plastic here because a lot of forms will fit in here. There are a few that don't, but I'm going to go with that one. I'll say what afterwards. Any examples matter, any kind. Butterfly, like it. The other class did babies. So at least we got living things on the board. Lead. That is over here. We need some more in this area. Yogurt. Some good gurt. Window. With like the frame and everything, or just like a piece of glass? Window plus frame. Fiberglass. I'm not entirely sure what fiberglass is, because it's spun glass. Is it pure spun glass? Yeah.
I think it's like shredded up glass.
It's shredded up glass. In that case, it's just going to go here. A napkin. A napkin is essentially wood with some extra stuff thrown in. It'll have some minerals put in for whitening often. If you're the type that eats paper, your paper's not pure wood. It's got some wood fibers, but it's got a lot of salts and other things that they, not like table salt, but whitening agents and caking agents they add to it that you're also eating to give out that nice little flavor. We need more here. What did someone have for breakfast this morning to drink?
Water. Oh, wait. Water.
We already got water.
Juice.
Juice, what kind of juice? Apple juice? Was it filtered, pure, like you could see right through it? Or was it like really organic and lots of guck in it? Pure apple juice. So, yeah, perfect. Apple juice is really common, yet we have OJ, and everybody knows what I mean, but nobody ever says AJ. Prejudiced. Any more we can put in this column, knowing pure apple juice?
Oh, wait. Let me think.
Yeah. Yes.
Like a transparent plastic. What?
Transparent plastic.
That would be.
It would be the same as this one.
It would be. What about your Thai? Pineapple juice.
Thai would go, is it filtered pineapple juice?
Yes.
So pure juice would go there. What else do you drink?
It's like coconut water.
Coconut water would go with milk.
Isn't milk on it, right? Isn't milk is in the other one? Oh.
It was there the whole time. What was I drinking in here? Coffee.
I wrote apple juice in the wrong column.
What?
No. I did, not you.
So, black coffee
Black coffee?
would fit into there,
What?
assuming it's well filtered and it's not like gucky. Yep.
I need like metal alloy.
Ooh, an alloy you could technically put in here in many cases. It's a weird type, but yeah, it goes in there. Ooh, great. What kind? What do you like to drink? Like vodka?
It's getting really
Pure vodka, yeah. Vodka,
Spirits.
American beer. Whereas in here would be like, or a better way to say might be commercial. Also non-fizzy. Got to put a lot of disclaimers there. Whereas here, if you had like homemade or craft beer, it might go in here. Also, by beer, we are of course, talking about root beer.
Homemade beer.
Of course.
What about the alcohol we used in the experiment last class?
Isopropyl alcohol. Excellent. We're getting some more on here. Can anybody get some more in here? Because now we've got lots everywhere. What's this column? Get some more in here. Yeah. What? Sorry. What did you say? You got quieter. I'm sorry, I think I made that worse. Vinegar! Oh, fantastic. 100% vinegar?
Say yes.
It's not. Excellent, that was a nod. I'll take it. Pure vinegar. Because I can take and I can go here and go house vinegar. But pure vinegar goes there. Anything else that we can put in there? Carbon dioxide. Nicely done. Now we're starting to cook with fire. Hopefully we can see it. Is that anybody? Can anybody name these columns? Name a column there, and then I'll go there. Yep. Ooh, close. They all have molecules, but there's certain types that don't have molecules. But you're on the right track because it's compounds. And the reason I'm being technical about it is no one said table salt, but table salt is a compound that's not a molecule because it's an infinite repeating pattern and doesn't end. But they all have formulas which you identified. Yes?
The far right is pure.
Oh, no, behind you. Oh.
The next one, like on the right, I think it's elements.
Elements, excellent. Guy? No, that's as far as we got. Anybody know these ones? I've asked you there.
The middle one is pure elements, like pure stuff.
Ooh, these are not pure substances, actually.
No, the middle.
Oh, the middle! The middle one's pure substances. You are correct. But are these not also pure substances? So pure substances isn't a column heading, but it is under here. The middle one, technically, you're on the right track. Like every piece looks like every other piece in here. But if I have a cup of coffee and you have a cup of coffee, are our cups of coffee the same? No. So these are not necessarily pure substances. And different parts of coffee, could they theoretically have slight differences between them? Yeah. So our pure substances are actually over here. Only elements and compounds can be pure substances, because every part has to be the same as every other part. But we did get something else on the board, so that's excellent. I think you were next. And then there? Yes. Yeah, Geek, go.
The one left in the middle is homogeneous mixture.
Ooh, yes. But not just left from the middle. Now you said two things. So you said this, right?
No, like the one with milk and honey.
The one with milk and honey. That is a what?
Homogeneous mixture.
That is a not a homogeneous. That's a heterogeneous mixture. But what you have identified is all of these. If these are pure substances, these are all mixtures. So the only question is, what kind of mixtures? Now, we've also said homogeneous and heterogeneous. Does anybody know which columns are homogeneous and which are heterogeneous? Which columns are homogeneous and which ones are heterogeneous? Homogeneous, everything basically looks the same all the time. And it's all just about looking the same. And which ones can look different?
Homogeneous is like milk, honey.
Homogeneous, if you were to look at milk under the microscope, you would see globules of fat. Honey can get awfully close, but it actually has other stuff in it. So it's more of a suspension than it is the other one that I'm not going to name because we're going to try and get them. But it's not quite. If you add water to it and you really filter it, though, you can get it in there. But like if I go to this one, yogurt is globules of fat. You look at it under the microscope, all parts look different. Maybe I need some more examples up there. We've got milk. I would also put up here a fruit smoothie. Salsa.
So is it heterogeneous mixture?
So, yeah. On this side, we have heterogeneous mixtures. And part of the problem is we include, does it all look different? And we include under the microscope. Honey does kind of look the same, but under the microscope, there are bits in it. Milk has big chunks. If you look at milk under the microscope, you can see the big chunks of fat. And we can see that it separates. If you ever, have anybody ever had like, or been around like non-store-bought, like actual, like from the cow fresh milk? What happens if you leave it overnight in the fridge?
It's like,
It's what?
it's like moldy or something.
Oh, not overnight in the fridge. Oh, milk will last overnight in the fridge.
It's like, I forget what it's called, but there's stuff on top.
Yeah, all the cream rises to the top. So all the fat, just like if you have oil and water and you shake it and it's all mixed up, the fat will all just slowly rise to the top. And whereas when they buy homogeneous milk, where they've taken milk and they've made it homogeneous, what they've done is they've just spun that through either a sieve, a really fine sieve, or literally with blades, and cut up the fat so small it's really hard for it to then come to the top. It's mixed so well. Yeah.
Is it suspension?
Oh, yeah, So this one is a suspension. And if this is heterogeneous, then all of these are homogeneous. So pure apple juice, every part of the apple juice looks the same, and that's why I had to ask, is it like natural apple juice with all the gunk still in it? If you didn't filter it really well, apple juice could belong in either of these. And a lot of these, if you talk about like, is it really well purified, is it not purified, you could probably get honey that actually could move if you made it very pure, or it's fake. A lot of honey nowadays, because honey is so expensive to grow, the bees are apparently dying. You just make rice sugar, you boil some rice and make a rice syrup, and then add some flavorings, and you have like really cheap honey. You sell that as real honey. What's this column called? So it's a homogeneous. Everything looks the same. We've got juices in here, black coffee, vodka.
Liquids?
They are all liquids. What kind of a mixture is a liquid and pure? For chemists, alcohol is in fact a solution. But at Brentwood, alcohol is a suspension. I don't know if you've ever heard this one before. What is like, it's a butterfly, it's concrete, it's wood, it's a ceramic mug, it's your desk, it's your chair. I don't know how natural, I mean, everything's natural. Name one unnatural thing, other than my brother. Because at some fundamental level, what we mean by natural is like it was growing somewhere in nature. And like, if we made it, but like, that means if we made it, like anything made of wood is still unnatural because we made it. Every piece of your desk was taken out of the ground or made from things taken out of the ground or grown. So there's technically nothing that's unnatural. There's just human made and not human made. But like, what's the difference between a beaver dam and a human hydroelectric dam? And that's that the beaver dams suck. They're terribly built, and they're not very efficient. They destroy sections of the environment without doing an environmental impact study. Human dams, much better. Last longer, provide power for humans. This is known as a mechanical mixture. So the entire thing, when someone says something's natural, it's just shorthand for human-made or not human-made. Where it gets weird is when they say natural is better. And it's like, well, I don't know. A bear with syphilis is natural, but I'm not sure it's better if you meet it in the forest. Lots of natural things. COVID's natural. There's a ton of things that are natural that aren't good. There's a ton of like things that aren't natural that are fantastic. Like, I like my children, but I love my iPhone. So, proportion is everything. Okay, what's the difference of heterogeneous?
They're not like finely mixed together.
Not finally, you can see it,
Yeah.
see the differences. Homogeneous, cannot see the differences. We include microscope because the original definition when they made it, that says scope. I think I overlapped my C and O.
What's the first word?
Hmm?
What?
Ink, including. INC period, I had shorthand, sorry. Maybe I shouldn't have done that. And, ooh, it is 1 o'clock. I have run out of time. Grade 9s and 10 classes, if you're new students, your teacher is allowed to dismiss you at 1 o'clock rather than 1:15 so that we don't overwhelm the lunch line. And then grade 11 and 12 teachers are not. And then some of them do, and then it gets overwhelmed at 1 o'clock anyway. But you are officially the ones that are allowed to go. We will continue this next day. Your lab is due next day. I also have to run to a meeting myself at the dining hall, so this works out very well.